All right, excellent. So, good morning, everyone, or I guess it's afternoon now. My name is Jonas Helgertz, and I will be talking about the linking strategy that we've been developing within this project. It's wonderful to see so many people here, and I guess I will also take this opportunity to thank you guys for forcing me to get out of my typical pandemic outfit, which is considerably less flattering than this. Let's see if I can get rid of the video, or here we go. Okay, excellent. So before we start, I'd like to acknowledge this is a group effort. We've been working closely with Joe Price at Brigham Young University. Other people that have been instrumental here are obviously Steve Ruggles, Kathy Fitch, Jacob Wellington, and Kelly Thompson. I think that's it. So before we get started here, I looked at the survey responses that you guys sent in, and I think I have a pretty good idea of at least what some of you guys would like to use the linked data for, and also a bit about your background in terms of how much you know about how people link or how we link data, and et cetera, et cetera. So I will start with a very short but still an outline or a summary of existing automated approaches to linking historical administrative records, basically outlining some fundamental differences between certain methods and kind of get you an idea, or kind of provide you with the fundamental information that you need in order to a little better understand what it is that we have tried to do and how that differs from other approaches that are out there. I will spend the majority of the time talking about the MLP approach, trying to illustrate to the best extent that I can some of the kind of the key rationale that's been going into what we're doing. Lastly, because I know that some of you are interested in how the MLP project compares to other methods or other data releases, such as the census linking project, I will be comparing a little bit the output that we are getting to outputs that is obtained using other methods. The purpose here is not so much to try to convince you guys to use MLP data instead of other data, but kind of to provide you with some relevant information that will help you make that decision yourselves. I encourage you, if you are interested more in the MLP method and what we've been doing, that you go into where you download the data and actually download the working paper that we've written that outlines the method in much greater detail than I'm able to do during this hour. So a few of these things will be extremely evident to you guys, but the point of departure, what we're trying to do is obviously that we're using different sources. In our case, we're using census data. For example, we're using the census from 1900 and trying to link to 1910, trying to link records in 1910. So the basic idea or the basic aim is to develop a method, or to find a way to best find records in source B that corresponds to a given record in source A. This may sound very, like a strange way to kind of even to talk about it at this very, very basic level, but it's still important because it kind of highlights that at least in theory, you need to figure out how to kind of limit who you are comparing. right? Who among who are you trying to find the person that you're linking? Now, a lot of people, maybe some of you, have spent some time, doing genealogy and stuff like that, trying to find your distant, your relatives. And in theory, in many cases, finding any one match is pretty straightforward. And I think it's easy to understand this if you're thinking about someone who you have a lot of prior knowledge about. For example, you know that your grandma, at some point, she moved from Pennsylvania to Illinois, for example. That will be useful information when you're going in to browse, ancestry, census records to try to find the record that corresponds to your relative. We're talking about linking people who we really don't know anything about. That being said, people with extremely uncommon names, for example, will obviously be more easy to find than people with very, very common names. Another thing that complicates things when it comes to linking historical census data is that they are very messy. So what you need to understand is that back in, say, 1900, the enumerator would go door to door and interview, typically, as far as I understand, I'm not the authority when it comes to this, but typically would interview one individual in a household about who is living there. And as we will see later, there's a bunch of information that the enumerator would write down, not only names and ages, but in some cases also occupation, state of birth, et cetera, et cetera. In certain households where, this is, again, historical times. So some of the things that we might take for granted today that we know exactly when we were born, for example, that might have been less the case 100 years ago. So in other words, information changes over time, or in some cases it changes over time. So information that in theory is time constant, that never changes, such as, year of birth, place of birth, etc., that may actually change. In addition to that, the whole digitization process, because we're working with digitized data, right? We're not working with the original source material. This, in many cases, was digitized by people who were not native English speakers. In addition to that, in some cases, the person writing down the information did so in a way that was very, very difficult to read. So in practice, this makes things quite difficult. When it comes to different linking methods, and we'll be getting back to this a bit later, we can differentiate between two different methods, fundamentally two different methods, deterministic and probabilistic methods. Probabilistic method is what we're using in this project, which is a more nuanced way of identifying matches, where essentially a score is provided to any given one-to-one combination of record, in identifying the degree of similarity between these two records. A deterministic method has some quite significant advantages. It's more easy to implement. It requires less input from the researcher or the research team. For example, one thing that we will be talking a little bit about later, something called training data, is not required when you're using a deterministic method. One thing that all of these methods have in common is that as a result of the messy data, it means that if I'm trying to find an individual that I have a record from the 1900 census, if I'm trying to find that individual in the 1910 record, it's not so easy, or it's not necessarily the case that I can limit the individuals that I'm looking at as potential matches to individuals who have the names, the exact same name as the person that I'm trying to link, the same birth year as the individual I'm trying to link, or the same place of birth as the individual that I'm trying to link. Again, because of all these things, because of all the messy aspects of historical census data. But in both for deterministic and probabilistic methods, a point of departure is to try to constitute or to try to define what constitutes the universe of potential matches. And what I mean, I will say this several points during the presentation, universe of potential matches. And what that is that from census A, we're trying to find individuals in census B. Universe of potential matches are individuals that I will be comparing a given record with. All right. So, what is always used are what's called blocking criteria, and they are employed to limit the number of comparisons made, because as is easy to understand, we're talking about huge data sets. We're talking about millions and millions of observations. And every one observation from source A or census A in one case will be compared to a number of records from source B. The more limited that we can make this number of comparisons, the more computationally tractable will the process be. I think this makes sense, right? So we define our university of potential matches through blocking criteria, which helps us to identify, or what we're aiming to do is to identify the appropriate universe of potential matches, right? Something that we want to make as small as possible, but we also want to make sure that within this universe, we will be able to find the true match. Typically or consistently, we are within the literature and all examples that I'm aware of, what's typically used are consistently and reliably reported information from both sources. So typically blocking criteria are defined based on first and last name similarity. So there are ways to, there's Yarr-Winkler score, for example, which compares the degree of similarity between two different strings. Typically above a certain threshold, that means that these records will belong to the universe of potential matches. Typically, one blocks on place of birth. So what that means is that for a given individual born in New York State, if I'm trying to find that individual 10 years later, I will only be looking at other individuals, or I will only be looking at individuals who were also born in that state. Naturally, what this means is that if this individual change, or if this information changes, or if there's an error here, the true match will not be among in that pool of potential matches. Year of birth is typically information that will change over time, or will vary slightly. So typically plus minus 3 years is pretty common, and normally we'll be blocking on gender. Now, there are cases in the data where individuals actually switch genders, or we don't actually think that they switch gender but necessarily, but that there's enumeration error or reporting error or something like that. In theory, one could use other characteristics as well, but these are the typical blocking criteria that are used and that we're using as well. So once a universe of potential matches has been defined, that means that for each individual is compared to multiple potential matches, right? Based on these blocking criteria. And in order to determine a match, that means that in order to determine a match, two criteria need to be fulfilled. First, a given one-to-one combination of records. So again, if we're talking about 1900 and 1910, a given one-to-one combination of 1900, 1910 records must be considered good enough, all right? And here it differs depending on whether we're using a deterministic approach or a probabilistic approach, where where again, a deterministic approach typically relies on or requires there to be an exact name match, for example, and exact match on year and state of birth. So, conditional on those things being true, that constitutes what is a good enough match, right? So it's above the threshold for what is required, or it passes that threshold. The probabilistic approach instead uses an estimated similarity based on frequently multiple characteristics. But again, the logic is the same, that it needs the similarity score needs to exceed a given threshold in order to be considered a match. The second criteria is that the given combination of records need to uniquely and sufficiently superior, need to be unique enough and sufficiently superior to the next best match. So what this means is that if there are multiple potential matches that are equally good, or where we're unable to distinguish between equally good potential matches, we will be unable to determine a match, right? So that's kind of the game plan. So at this point, we've determined the blocking criteria, we've defined the potential matches, and we've determined our links based on these two criteria, that the potential match is good enough and that it's sufficiently much better to the second or the next best potential match. There are a number of different considerations to take into account when it comes to evaluating different ways to do linking. One important one is obviously, which is always the case, of course, in research, replicability, right? Is it possible for anyone else to just replicate what it is that you're doing? From this perspective, probabilistic approaches are slightly more tricky, simply because they are basically always relying on training data that's generated by the researcher themselves. So if someone else were to create their own training data and replicate a probabilistic approach, they might come, even though they perfectly replicate the approach, based on the difference in training data, they may come to slightly different conclusions in terms of who they are able to link. Other considerations is obviously linkage rates, or at least when you have training data, you can calculate what's called recall, which is the share of actual matches that your algorithm is able to identify. Linkage rates more broadly, if I'm trying to link 1 million individuals, what proportion of those individuals am I able to link? Obviously, what we would like is to link a greater proportion of individuals, right? This is something that's a little bit problematic, because if linkage, it's reasonably straightforward to obtain higher linkage rates. We simply just lower our thresholds, right? We make it easier to define links. In doing so, we will automatically lower our precision, or the accuracy of our links. So we will be elevating our false positive rates, which is problematic. So these two, recall and precision, they tend to, or they always go in different directions. So that's another important consideration. Lastly, the sample that you end up with will not necessarily be perfectly reflecting the underlying population. So you may have issues with representativity. Obviously, whatever conclusions that you are able to draw will fundamentally be linked to the population that you are able to examine or study. So after this kind of more lengthy than I hope, but background, how does the MLP approach differ from other existing methods? I would say that it's the 2 points here. The two first ones are the most important ones. The third one is more of a caveat, but one that I find is important to point out anyway. One is that we are exploiting a more extensive set of individual, household, and contextual characteristics when we are distinguishing between potential matches. As Steve mentioned in his previous presentation, typically individuals, or typically in linking approaches or in linking efforts, there's been a more or less unique reliance on characteristics that don't change over time. So theoretically immutable characteristics such as the name, age, place of birth, etc. The second one, so the first point is important. So is the second one. We are employing a two-step linking process, where in step one we identify high confidence matches through point one, where we're using more extensive set of characteristics, and in step two directly follows step one, where we attempt to identify matches in households of individuals linked in step one. This will become clearer as I move forward here. To date, we are only able to provide links between subsequent censuses. So we have links between 1900, 1910, 10 to 20, etc. Our method of relying on this more extensive set of individual household contextual characteristics, it's likely to provide diminishing returns as the time between the censuses increases. So that's just something to bear in mind at this point, because as much as we love the results of our linking efforts, it's still important that we kind of point out the potential shortcomings of this method. So again, rationale. So the rationale for step one. So most linking efforts solely rely on immutable characteristics. Name, we're only linking males because males don't change their names. Gender, year, place of birth. So these are characteristics that we link on and we use as linking variables. The question is, though, in historical linking, in historical data, how immutable are really the immutable characteristics? And what I mean by that is through this very messy process of digitization, it's questionable to the extent any characteristic can really be truly immutable in historical census data. So what we were thinking when we was that we think that using fewer linking characteristic will imply a greater prevalence of indistinguishable matches, something that should affect our recall or our linkage rates. Additionally, hold on, I gotta move this here. Exploiting more information facilitates accurately identifying accurate matches, which is something that should elevate or enhance the precision of our links. So our hope was that through using a more extensive set of characteristics, we would not only obtain more precise links or more accurate links, but we would also be able to get more links. So let's look at a couple of examples or kind of illustrations of this. So suppose that we want to link an individual named Arthur Thomas, who's a male born 1893 in Pennsylvania. So you'll see down here. So this is just how the data could potentially look. I'm going to bring up my highlighter here, the laser pointer. So here we have the information from the source A. That could be the census 1900, for example. So this Thomas Arthur is linked to 6 individuals in source B, the census 10 years later, where the names are exactly the same. So these are 6 different individuals named Thomas Arthur who were born in 1893. Okay, so this is kind of how our data looks, or this is how the data looks once we've created our universe of potential matches. So in this case, while this isn't an extremely common name, there are 6 perfect matches on name, gender, year, and state of birth. So you can easily see based on this that it would be quite the challenge based on this kind of information to distinguish between these matches, right? What we were thinking when we were looking at the census data, and this is of this very individual, you have Arthur down here, Arthur Thomas, son, born in 1893. What we were thinking is that there's a lot of additional information at the household level, but also at the contextual level that could help us better distinguish between individuals. So, for example, we could use information on other household members. We could use information on those other household members' place of birth, where the individual lives at the time, et cetera, et cetera. So this is how the data looks when we've added information from the 1900 and the 1910 census on the individuals, the potential matches, fathers and mothers. And you see in this case that by adding this information, it becomes pretty easy to identify which one is the right match, right? It's the second one here, where we have a William and Margaret, and we have a Will and Margaret 10 years later. So our rationale was that we want to be able to, or we want to use this information, or we want to train our algorithm to use this information when distinguishing between matches, just as I am doing right now as a human being. Another example is this. This is one, if you've heard a version of this presentation before, this will be a familiar example. Otherwise, this is a very typical example, and which I think illustrates this so well. So again, here you have the individual that we're trying to link. It's a Robert Beach, born in 1869. These are the four best potential matches for this individual. We have a Robbed, which is obviously Robert Beach, born 1868. We have a Robert Beers, 1869, Robert Beers, 1870, and Robert Beers, 1870. So in this case, it's a little difficult because we can't really, it's not very interactive right now, but I would say, if I were to guess, that the majority of you, based on the information that you're seeing right here, would probably say that the first individual emerges. If you can determine a match here, the first one, based on just the name and birth year information, the first one would appear to be the best possible match. If we add information on, in this case, the spouse, and we've added the street names here, we see that it's not the first one again. It's the second one that's the right match. In this case, the person is married to an Emma in 1900, living on Walnut Street. And 10 years later, there's this Robert Beers has a spouse named Emma and also living on Walnut Street. And we've also calculated this a measurement of whether there are any shared neighbors between the 1900 and 1910 potential match. And there are in this case. So there's more information here that I could show, but you'll just have to take my word for it that this is, I mean, again, we can't say definitely that this is the right individual because we can't ask this person. They're dead. But it would appear to be highly unlikely to be anyone else. So this is what we're trying to, we're trying to use this information. We're trying to train our algorithm to use this information. So we're following Feigenbaum's regression approach, but we are extending the set of linking variables that we use. And this is just a side, just a very minor point, but we're using a logistic estimator instead of a probit estimator. But the key point is that we're extending the set of linking variables that we use.
Jonas, I'll interrupt briefly with a comment about street of residence not being a stable characteristic. So can you talk about migration within the US as it relates to the example you just shared? Thanks.
It's absolutely true that it's not a stable characteristic. So we use it, so the way that we have attempted to use it, and we have, actually, if you could just wait a couple of slides, I will go through the linking characteristics that we're using, and I'll get back to it, okay?
Thanks.
Okay, so we're using blocking criteria, very standard Yarwinkler, gender, state, and country of birth, birth year plus minus 3 years. Additionally, we use something in an adjusted bigram, and I'm not going to go into what that technically means. So if you're interested, do go ahead and read the paper. We use a pretty modest training data set of 3,000 men linked 1900 to 1910. And we believe that we've generated this data very, very carefully using Ancestry.com, and we've obtained about 45% confirmed matches. So we train the algorithm using train test split procedure, which is essentially that you're splitting the training data in half, you're training your algorithm on one half, you're predicting based on the other half, and using various thresholds for these, what constitutes a good enough match and how much better than the next best it needs to be. We optimize, we find the value that yields the highest MCC, or Matthews correlation coefficient, which is essentially a 0 to 1 measurement of linking performance that takes both precision and recall into account. We obtain an MCC of 0.89, a precision of 0.9, and recall of 0.87 in the training data, should be said. We're doing actually better than that, but that's in the training data, where we're a little bit more conservative when we're declaring matches. So here we have the linking characteristics that we're using. We're using a bunch of individual characteristics, household characteristics, and contextual characteristics. So we're using, as I said before, name similarity, birth year difference, whether the 1900 individual is a second-generation immigrant. We're exploiting differences in the year of immigration reported in 1900, 1910. We're taking into account the race of the 1900 individual and have an indicator variable for whether the 1910 potential matches of the same race, number of potential matches, et cetera, et cetera. These characteristics are pretty unique to our approach. I think we have indicators whether the father and mother is present in the household in both years. If that's the case, we also exploit the Yarwinkler score. We do the same for the spouse, and we create indicator variables for whether there are relatives present in both households or unrelated household members present in both households. So about the street name and so forth. So we also measured the geographical distance between the 1900 individual and the 1910 potential match. So street name it takes the value 0 if the street name variable takes the value 0 if either there is no street name in both records, or if it doesn't match. So it only takes the value 1 in this case if there is a match on that variable. We are aware of the, obviously there's a risk, that was mentioned by the person asking the question, that we're doing something to the migrants. But we've spent a lot of time looking at this data and carefully creating the training data to know that when the street name matches with two potential matches that are very similar, it's exceedingly rare. I don't think I've ever encountered a situation where they don't match, where it isn't a match. The same, we're taking into account geographical distance between the potential matches. Obviously, people did move. That being said, between two potential matches, with a very high name similarity score and everything else is exactly identical, in 95 cases out of 100, if not more, the true match will be the one who is who resides in the same county or county or state as the 1900 individual, compared to the other potential match who resides 500 miles away.
I'll share a question in the same vein, if that's okay. I'm wondering if you can talk about the impact of life transitions, such as marriage or anything else that might change household structure.
Yeah. So I would actually, if we could wait with that question until later, that if that'd be okay,
Great.
because I'll have some statistics that pertains to that too later. So we'll get back to that later. Okay, is that okay?
Great. Thank you.
Okay. So that's basically step one. So at the end of which we have a bunch of links, and this takes us to step two, where the underlying rationale for this is that the knowledge that many individuals are difficult to link due to the failure to appropriately distinguish between individuals in the correct pool of potential matches. So, for example, people with very common names, et cetera, they are just very, very difficult to link, even if you're controlling for, even if you're taking into account all of these linking characteristics that we're using. Also, we know for a fact, or we can easily see in the data, that some of the characteristics that we are in step one, and that other methods are treating as immutable, they are not in fact immutable. I mean, it's in this historical data, it's reasonably common for people to change their first name or to go from a John W to a William J. These would be cases that are really difficult to link with any traditional or normal, typical linking algorithm. There are also quite a few cases where there are more substantial inconsistencies in, for example, year of birth or place of birth, as well as cases where people's gender or how their genders are reported actually change. So what we were thinking is, or what we noticed quite easily in the data, is that, or what we were thinking is, to what extent can we use links that we've established in step one to kind of severely restrict the universe of potential matches, while at the same time relaxing these typical blocking criteria. All right, so I'm going to try to illustrate this. So in this case, here you have two real examples from 1900 and 1910. See, we have an Isaac B. Cody, born 1869 in Alabama, years married 1, place of residence Lauderdale, Alabama. 10 years later, he is Idlia B. Cody. He's also born 1869. Now he's born in Tennessee, 11 years married, Lauderdale, Alabama. We have a Martha J. and Albert O. In this case, what we were able to do with step one was that we were able to link Albert O. Okay, Albert O, a male, because again, we were able to use, all these, characteristics that I've already outlined for you. So, but we weren't able to link Isaac B, and obviously we weren't linking women, so we weren't able to link Martha J. What we were thinking, or what the rationale for step two is, what if we try to link Isaac B and Martha J, but we limit the universe of potential matches to individuals in the same household as the person that was linked, Albert O, 10 years later. By doing so, obviously, the potential matches in the household is just 1, 2, 3, 4. And you can see that these two individuals were born after 1900. But still, in theory, birth year would be off, so at least in theory, that's a possibility. At the same time, what we could do is that we could relax these other blocking criteria. So we wouldn't have to, since we've limited the universe of potential matches so much, we can relax these other criteria. We can relax birth year, we can relax state of birth, we can relax sex, even. So what we do is that we simultaneously relax and restrict the blocking criteria. And in step 2, we here exploit the confident links from step 1 to link previously unlinked individuals in those households, in those 1910 households or census A households. So in step 1, we have these blocking criteria that I talked about before. We have the adjusted bigram match, gender, state, country of birth. This should be 0.7, my apologies. First and last name, Jar Winkler score, and year of birth. Whereas in step 2, we relax all these blocking criteria and we relax year of birth to be plus minus 10 instead. Okay. So in this case, so Albert O. Cody anchors these two households from census A and census B. And since we've relaxed now even the gender blocking criteria, that means that Isaac here will be linked to both Idlea B and Martha J as potential matches. Martha J will be linked to Martha J and Idlea B. So, this change in the blocking criteria, it results in a substantial reduction in the mean number of potential matches per census A individual. So it makes it computationally much more easy for us to do. We created training data separately for a training data set that originated from the step 1. And as you can see, we obtain a considerably higher matching rate, 61.4%. In this case, we obtain an even higher MCC, 0.96, and we obtain very, very high precision and recall. And in this case, we rely on only individual characteristics and a much less extensive set of characteristics. For example, we're controlling for name similarity, birth year difference, whether the individual in 1900 was foreign born or in census A was foreign born. There's a match in birthplace, match regarding race, match regarding gender, marriage duration mismatch if there is such information, household position match, first name initial match, middle name initial match. So this, again, I encourage you to read the paper if you want to find out, because the variables are quite more elaborately explained there.
I have a quick clarification question. When you're talking about matching rates, can you confirm, is this the portion of male matches?
No. You mean here, the precision? Or here, match rate. No. So sorry. So the step 2, where the training data set is both men and women. Men and women from households where we've been able to anchor one individual. Okay?
Thank you.
So in step 2, we're linking both men and women. So the implementation of this algorithm, this 2-step algorithm, is fully automated in software called HLink that's been developed again by our IT staff, Kelly Thompson and Jake Wellington. It's available at the UMN GitHub repository. I'm not competent to talk much more about like programming language and all that. So, but I know that Kelly is listening in. So if you have questions about that, I'm sure she can address them later. But what I do know and what I can tell you is that it, especially for data that is similar to the U.S. Census data, it should be reasonably straightforward to tweak the HLink software to be used on your specific data. So basically, this is the MLP algorithm. So we first select men from census A. We'll link them to a universe of potential matches from census B, following the step 1 blocking criteria. We identify links using the algorithm for step 1. We then select the unlinked census 1 household members, and we link them to their respective universe of potential matches, following the step 2 blocking criteria. And this should be step 2, obviously. Those links are identified using the outlined algorithm. So we have, right now, as I told you, all we have is that we've just created links across 10-year intervals. So we have 1900 to 1910, 10 to 20, etc. Approximately half of the populations are women. Not quite half, but pretty close to it. And what you can see is that it's also obviously possible to link them further. So you can use the 1900 to 1910 links to link to 1920 to 1910 to 1920 links, and so forth. So if you were interested in, for example, examining individuals from 1900 through 1940, we could at this very point offer you 4 million individuals to study. So what we've done is so through our collaboration with Joe Price and Brigham Young, we have been able to check our linking performance, kind of out of sample checks. So what we've done is that so they have access to a family search. I don't know why it says FT, it says FS. I'm sure it's my mistake. It should say family search database. So what we've done is that we've randomly drawn 500,000 links from each respective crosswalk, and we have checked them against the family search database. And here you can see the proportion of cases where the family search match is the same as the MLP match. The family search data, which we have reason to believe is extremely accurate, so we have a very, very high precision or accuracy. We've also conducted a separate manual check of our links. Again, a random sample, also suggesting a very, very high accuracy or precision. So the last 10 minutes I will spend on, and this is again also in the paper. So it's a case study that we did because, of course, it's relevant to understand how our algorithm compares to other existing and frequently used algorithms and data that's out there. So what we did was that we wanted to compare the MLP step 1 algorithm to the what I'm calling here the Feigenbaum approach. It's the using a more limited number of individual level characteristics, basically following that very, very nice and 2016 paper, as well as the ABE links that have been provided at the Census Link, I believe the Census Link website. A disclaimer here: the results from the paper, I have no reason to doubt them whatsoever. But the paper is currently under peer review. I just want to point that out. But the linking protocols were implemented exactly as instructed, and reported checks are made. The checks that I'll be reporting are made using external databases. So me or my team had nothing to do with creating these statistics. So what we did was that we extracted 100 randomly selected males from the 1900 full count census, and we linked them to 1910 using these 3 different methods. Again, the MLP only step 1, the Feigenbaum methods, which is here just a more limited set of individual level characteristics used to link, but we used the same MLP training data. So it's using the exact same training data as the MLP here. And the ABE. So we're trying to link the same 100,000 individuals. And I'm going to try to go through this pretty quickly. So overall, looking at the linkage rates, linking these 3 different, using these 3 different ways, you can see that the confirmed number of links differ quite substantially between the 3 different methods. The MLP step 1 links about 46% of these 100,000 individuals. The Feigenbaum method, 28%, and the ABE method, 27%. As you can see, there's a fair amount of overlap among declared matches, which indicates that if 2 matches declare, or if 2 methods declare a given record, the given combination of record to be a match, they're generally in agreement. So one thing that we can learn from this is that there's a considerable overlap between the 3 methods, but that you're getting a sizable chunk more links using the MLP method. And again, this is just step 1, so this is just the males that we're linking. Again, assessing accuracy. This is again done using this external family search database. So what we're doing here is that we're checking the links that are obtained these three different methods against the links that are in the family search database. So we're checking to what extent they are identical, or they are true or correct according to the family search database. A few things that I want to point out. Confirmed links, here again, you see these are the same figures that you saw before, 46,000, 28,000, 26,000. The agreement rate with the family tree database, oh, that's where the FT is from. Agreement with the family tree database is tells you that if the link is in the family tree database, to what extent is it the same link? And you see in about 98% of the cases, we are correct. It's lowest using the lesser set of individual level characteristics, and the ABE method here is somewhere in between. When both algorithms, so when both our method and the Feigenbaum method are in agreement about a given link, in almost 99% cases, is it the correct one according to the family tree database or family search database? When we and the ABE are in agreement, we are at 99%. So again, if there's overlap, we're right. The cases where only we link them, so in 24,000 cases, it's 97% correct, 97% compared to the ABE. When only the Feigenbaum or the ABE method links them, you can see that the agreement rate with the family search database is considerably lower. So it would appear that, or what we learned from this is that if we are in, if we're overlapping, we're both right. If we're not overlapping, but we are declaring a link, there's almost no difference between, we're almost always right as well. When the other method only declares a match, the share of links that is correct is considerably lower. One important thing here that Steve mentioned quite a bit is when it comes to representativity of links. That's also a very, very important aspect of this. And what you're seeing here are the kind of summary statistics, or just comparing the baseline 100,000 individuals that we tried to link. So in other words, just randomly selecting 100,000 individuals from the 1900 census, we would get 88% whites, 11% blacks, and 1% others. Among the links that we obtained using our MLP method, you can see that we obtained we got an overrepresentation of whites, right? We got 93% whites, 7% blacks, so an underrepresentation of blacks, as we would expect, but still. You can see that there's no huge difference here when we're comparing the Feigenbaum and the ABE. The ABE seem to be doing slightly better, but it's no large difference, no big difference. As could be expected, given our method, we are overrepresenting individuals who are residing with spouses and who are residing with parents. But to some extent, so do the other methods. But in general, both the Feigenbaum and the ABE method are doing better when it comes to the representation. That is, without a doubt, true. Especially if you see down here where we come to the lifetime migrant statistic, which is here only calculated for the US born, where in the census we're at 26% lifetime migrants. That is, that the state in which you reside is not the same state in which you were born. Through the MLP links, we get to 21%, Feigenbaum 27, ABE 25. So that is definitely better. So that's kind of takes me to my conclusions.
I was just going to give you a 2-minute warning, Jonas. Thank you.
Oh, excellent. All right. So so this has been a pretty very, very brief introduction to the MLP method, which I hope you agree or can feel that it represents definitely a new approach to linking historical U.S. Census data. I think it's fair to say that it offers several important advantages. We're linking larger populations. We're linking them very, very accurately, and we're linking women as well. However, representativity is a very important dimension when it comes to linking, and so is accuracy. So I personally, at least, I feel like the representativity issue is something that's been discussed more frequently when it comes to this, and accuracy slightly less, because I think that whereas the other methods are doing better when it comes to representativity, I think I think one needs to be a bit wary of what the greater proportion of false links, what the influence that has on the results that one obtains. Coming steps within the MLP project is the one thing that I want to highlight, especially apart from linking 19th century data, which we were just done calibrating the algorithm for the 1870 to 1880. So hopefully before not too long, that should be coming up. I'm personally very excited about implementing a step 3, where what we're going to do is that we're going to take out those individuals that we've already linked, because we have reason to believe that they are linked with very, very high accuracy, and trying to link a substantial portion of the remaining unlinked population. And our ambition and our hope and our belief is that we will be able to obtain a sizable chunk of these, hopefully, of these populations that are more difficult for us to link. So migrants, minorities, etc. As Steve mentioned, we will also be linking to other administrative registers, and at some point we will also be linking across time periods that are greater than 10 years. But again, that will, the longer the time period, the more adjustments to this method, I believe. So thank you for your attention.